In this video, I'm gonna show you how to build a robot car using a Raspberry Pi 5, an Arduino Uno and ROS2. We will control the robot remotely using a keyboard. We will be sending commands to move it forward, backward, left and right by pressing different keys. The robot is equipped with an USB camera and I'm gonna show you how to stream the camera feed over a network and visualize it in real time on a computer. And I'm gonna show you every single step of this process, assembling the physical structure, wiring and connecting all the electronic components, and writing all the code and setup needed on both the Arduino Uno and the Raspberry Pi. This project is ideal for people who are getting started in ROS2 and robotics. It brings together mechanics, electronics, programming and problem-solving skills. My name is Felipe, welcome to my channel and now let's get started. And this is a very high-level overview of all the different components which will be involved in this process. We will be using a Raspberry Pi 5, an Arduino Uno, two different motor drivers L298N, and each one of these motor drivers will be driving two motors. Then we will be using a 9 volts battery in order to power the motor drivers and a power bank in order to power the Raspberry Pi 5. And remember, we will be using an USB camera connected to the Raspberry Pi 5. So this is going to be a very awesome tutorial and I'm going to show you how all these components fit together and how we're going to create this robot car. So now let's get started with the physical structure of this robot. Let me show you how to assemble the physical structure. Let me show you something which is the motor driver we will be using in this project in order to control the 4 motors we will be using in this robot, which is the L298N motor driver, right? This component over here. Let me show you a few details of how it works because I think this is going to help you a lot in this project. So you can see we have these pins over here. We have a lot of pins, but we have these 2 pins over here and these 2 other pins in this other side. And these are the pins we will be connecting to the motors. I'm going to show you in a few minutes exactly how I connect the motors to these pins over here. Now let me show you something else, which are these 3 pins which we have over here, and these are the pins where we will be connecting the power supply in the motor drivers, right? The pin that's over here is where we will be connecting VCC, and then this pin in the middle is where we will be connecting ground, right? So these 2 pins go to the battery, right? We will be connecting the 9 volts battery in these 2 pins over here. That's very important. Then this other pin over here, we're not going to use it in this project, so it doesn't matter. We're only going to be using these 2 pins over here. And something that's very important, very important, remember we will be using the 9 volts battery in order to power the motors, and we will be using an USB cable in order to power the Arduino Uno. Something that's very important, please remember to connect the ground of your L298N to the ground of the Arduino Uno. Otherwise, you may have some issues. Otherwise, it's very likely you are going to have some issues. Now, let me show you these 6 pins we have over here. These are very important pins, and this is where all the magic happens, right? Because this is where we will be driving the motor. So we have 2 enable pins, and then we have these pins over here, which are in 1, in 2, in 3, and in 4. So enable A in 1 and in 2 are going to be driving this motor over here, and then enable B in 4 and in 3 will be driving this other motor over here. With each one of these components, we will be able to drive 2 different motors, right? So we will have 3 pins for one of the motors and 3 pins for the other motor. Something that's very important, please remember to connect the enable pins, all the enable pins, to analog inputs in the Arduino Uno. I'm referring to these pins over here, the analog input pins. You can use any of them for connecting the enable pins, or you can also use some of the digital pins over here. You need to look at the pins here which have like a character next to the number. Pin number 3, 5, 6, 9, 10 or 11. You can use any of these pins too for connecting the enable pins. And something else that's very important, please take a look at these 2 things which are connected to the enable pins. These things over here, they are usually there by default when you purchase one of these motor drivers, and the idea of using these things in the L298N is connecting the enable pins to VCC, right? So we will be connecting the enable pins to VCC, and we will not be able to drive different speeds. If you want to follow along this tutorial and you want to do exactly the same as I do in this tutorial, then you will need to remove these things which are connected to the enable pins, right? You will need to remove them, because otherwise you will not be able to work on this project the way I am working in this project. You can also keep the things here. If you don't want to remove them, you can keep them there, but if you do so, you will be driving the motor at maximum speed at all times. You will not be able to change the speed. So it's up to you. If you want to follow along this tutorial exactly the same as I will be working on this tutorial, then you will need to remove it, because otherwise you will not be able to change the speed of the motors. And that's pretty much all. So now I'm going to show you exactly how I connect these components to all the different motors, and also how I place these components in the physical structure of the robot. I'm not going to show you how to connect these pins over here to the Arduino Uno, because it's up to you. You can connect them anywhere you want, as long as you connect the enable pins to analog inputs, and also as long as you do not use the pins number 0 and number 1, because they are used in the serial communication. That's pretty much all for this part, where I show you some details about this motor driver we will be using in this project. Now let's continue. Now let's go here to the Arduino IDE and let me show you everything we need to do in order to make the Arduino Uno work as expected. So you can see these are all the definitions of all the pins we will be using in this process. These are the enable pins, and these pins over here are the ones we will be using in order to drive the motors forward and backward, right? I'm gonna show you in a few minutes exactly how to do that. And A and B are the frontal wheels, and then C and D are the other two wheels in the back. Okay, so let's take one step at a time, and the first thing I'm going to do is to drive only one wheel at first, only one wheel, so we make sure we can control one wheel perfectly, and then once everything works as expected, I'm going to do the same with all the four wheels so we can control the entire robot, right? I will be using this other camera over here in order to show you how everything works in the robot. Okay, so the first thing I'm going to do is to set up the pins we will be using in order to drive one wheel at first, right? And we will be using this one over here at first, and this one I have been doing some tests already, and we will need to control the enable B pin and then the in3 and in4, right? So pins number 5, 7 and 8, these are the pins we will be using at first in order to control only one wheel. So let me show you. The first thing I'm going to do is to set these pins as output. So I'm going here to the setup, and I'm going to do something like pin mode, enable B, output. Okay, and I'm going to do exactly the same for in3 and in4. Okay, and that's pretty much all. So this is everything we need in order to control only one wheel. And then here in loop, the only thing I'm going to do for now is to set the speed. I'm going to define a new variable, which is speed, and I'm going to set this value in 128 for now, right? And then the only thing I'm going to do is to write, I'm going to do an analog write to the enable B pin, and I'm going to write this value over here. This value over here ranges between 0 and 255. So 0 is the minimum and 255 is the maximum. In order to make it like halfway through, we're going to set it in 128. We can increase it or we can decrease it in a few minutes. This is only to make sure everything works as expected. And now I'm going to do a digital write of the other two pins in 3 and in 4, and this is going to be, in the case of in 3, this is going to be low, and then in 4 is going to be high. And if I'm not mistaken, we will be driving this wheel forward by running this command over here. So let's see what happens. That's pretty much all. And in my case, as I am a Linux user, in my case it's important to run this command over here before I use the USB port where I have connected the Arduino Uno. Let's make this a bit larger. I'm referring to this command over here. In my case, it's necessary to execute it before using the Arduino Uno in the USB port. I don't know why, but it is necessary in my case. So now let's move on here to the Arduino Uno. I'm going to upload the script and let's see what happens. And you can see that it immediately moves, right? So everything seems to be working as expected. Now I'm going to increase the speed. I'm going to set it in 200. And you can see that now it moves faster. If I set it in 100, you can see now it moves a bit slower. And something I've noticed is that if I set it very low, it's not going to move, right? For example, if I set it in 50, it's not going to move. So this is something we need to take into consideration when we are working in this project, that there seems to be something like a minimum speed for which the motor moves. I believe the minimum threshold is around 60, if I'm not mistaken. No, 60 is too low. 70 is too low as well. With 90, you can see it's moving. Okay, now let's repeat exactly the same process. I'm going to set it in 0 for now. Let's repeat the same process, but let's change. Now in 3 is going to be high, and in 4 is going to be low. And if I run the same script again, you can see that now it moves backward, right? So everything seems to be working just fine. Okay. And if I set the two in 3 and in 4 to either low or high, if I set both of them to either low or high, the motor is going to be stopped, right? But we can also stop it by setting the speed to 0. So that's going to be pretty much all for driving only one wheel. Now let's do exactly the same for the 4 wheels, so we can move the entire robot either forward, backward, left or right, right? So let's see how to do that. I'm going to define another function. I think it's going to make things much easier, which is going to be forward. And this is going to be something like this. Every time we call forward, we are going to, we can receive a speed, perhaps, something like this. And then we are going to repeat the same process for all the wheels, right? So this is enable A, enable B, and we need an enable C and an enable D. Perhaps we can set the speeds over here, right? It doesn't make any sense to set the speed here. Yeah, it makes much more sense to set the speed over here and then calling forward over here, right? Yeah. And then this is going to be in 3, in 4, low and high. Then let's also move in 1 and in 2. I'm going to set it in low and high for now as well. If I'm not mistaken, this is how we're going to drive this one forward. But if we're going to test it in a few minutes, if we notice it's wrong, we can just change it. And I'm going to do exactly the same for in 5, 6, 7, and 8. 5, 6, 7, and 8. Let's just leave it like this for now and let's see what happens. So let's set it in a value of 128, and also obviously I need to add all these pins over here to the setup, otherwise it's not going to work. So I can just do something like this. A, B, C, and D. Okay. And then the pin mode over here as well. Okay, this is 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so this is going to be pretty much all, and now let's see if it works. I'm going to upload the new script. Okay, now all the wheels are moving. Not all of them are moving forward, right? This one over here is moving forward. Also this one. And the other 2 wheels are moving backward. So the 5, 6, 7, and 8, I have to change these values over here. I have to do it like this: high, low, high and low. Let's see now. Oh, this is speed equal to 0. Let's change it to 128. Okay. Now it seems it's working. I'm going to make it a bit slower. No, let's make it 128. Let's do something in order to make sure it works. I'm going to drive it with this speed over here, but only for a few milliseconds, right? Only for 200 milliseconds. So we make the robot to move only slightly, and we make sure everything moves in the right direction. So I'm going to define a new variable, which is delay, and this is going to be equal to, I don't know, 200 milliseconds, like this. Then I'm going to do something like delay, or perhaps we can do something like this. This is only a test, right? We're going to change it later, but for now I think this is going to work. So let's define another variable, which is counter. This is going to be equal to 0. And if counter equal to 0, then this, and if not, this is going to be 0. And this is not Python. This is not Python. I know what you're thinking. Felipe, this is not going to work because this is not Python. Yeah. So this is going to be if counter equal to 0. Okay. Let's do something like this. Something like this. Okay. So let's see what happens. We have an error, which is speed. Perhaps we could do something like this. Okay, this should work. It worked, but it didn't stop. Let's see why. Oh, because I did not increment the counter. Okay, let's do it over here. Okay, everything worked as expected. Let's do it for a bit more, perhaps 500 milliseconds. Okay, and all the wheels moved forward, so everything is working properly. Now let's do the same, but another function, which is going to be backward, right? We're going to move all the motors backward. Let's see how to do that. I'm going to copy this function over here. and this is going to be backward. And now the only thing I need to do is to change all the values, right? So this is going to be, perhaps the easiest way to do it will be to do something like this, right? Okay, now let's see if it works. I'm going to do exactly the same, but instead of calling forward, I'm going to call backward. Okay, I have to be very careful because the table ends there and perhaps it fails, right? But yeah, everything is okay. Everything is working properly, and now let's work on two other functions in order to move the robot either left or right. I have been doing some tests already, and there are different ways in which we could do it, but the way I found that works best in my experience in the tests I've done so far is doing something like this. Let me show you. So I'm going to copy this one over here because this is going to be actually, we're going to move left and right, but also we're going to move forward, right? So this is going to be like a forward left and forward right? In order to keep it simple, let's add this functionality only, right? So if the user wants to move the robot backward and left or right, they will need to figure it out. So this is going to be something like left. Let's do this one first. So by doing everything that's over here, we're going to be moving the robot forward, but we want to move it left. So what I'm going to do is to just move three of the 4 wheels. I'm going to move 3 wheels forward, and the remaining wheel I'm going to stop it, right? I'm going to make it not move at all, and that's going to make the robot to move in the direction we want, right? So the wheel I wanna stop is going to be, if I'm not mistaken, it's going to be this one over here, right? If I'm not mistaken, it's this one over here, but let's see. So if we set these two values as high, this wheel over here is not going to move. So let's see if this is the wheel we want. I'm going to do something like this, and let's see what happens. Let's see what happens. Oh, let's do it again. Okay, so it's moving forward, right? It's not moving left as we expected, but everything seems to be working properly, meaning that it's moving 3 wheels forward, and then the remaining wheel, it's just still, right? If you look at this wheel over here, you're going to see it's completely still. Okay, so everything works properly, but the thing is, once we incorporate the Raspberry Pi 5 and the power supply, everything is going to be much more heavy. So by doing something like this is going to be enough in order to move the entire robot, right? Currently it's not enough because there's not enough weight in the robot, right? Let me show you something. I have the power supply over here, so I'm just going to show you so you can see what I mean. If I incorporate this power supply over here into the robot, if I just put it on top, this is something I'm going to show you better later on, but for now, just focus on, if I make the structure a bit more heavy, and I run it again, I'm going to run it for 300 milliseconds, or perhaps for 500 milliseconds, you can see that now it moves a bit to the side, right? So yeah, let's just leave it like this for now, and remember, everything is going to make more sense once the robot is fully prepared, right? It's fully with all the components and everything, because the power supply over here, if you have used a power bank before, you know that they are a bit heavy, right? So this is exactly what we need in order to make the entire structure more heavy, and if we stop only one of the 4 wheels, the robot is going to move to one of the 2 sides. So now let's continue, and we do have a problem though, because you can see that now here it says left, but the robot is not turning left, but it's turning right? So the only thing we could do in order to fix it is changing this value over here by right. And that's it. So this is the function we're going to use in order to move the robot slightly to the right. Now let's create another function which is left, and the only thing we need to do over here is to change what's the wheel we are going to use in order to just make it still, right? And perhaps in order to avoid making a mistake, I'm just going to copy the forward function, and then I'm going to make something like this. Okay, and that's going to be pretty much all. Let's see if it works. So this is left. I'm going to do it like this. Okay, so it's moving all the wheels excepting that one over there. So everything seems to be working perfectly. Okay, so now we are able to control all the wheels, the 4 wheels, and we can move the robot in the direction we want. Oh, we are making a lot of progress. And now let's do something else, because remember, the idea is to control the robot from the Raspberry Pi. So we will be instructing the Arduino Uno using the serial communication port. So we will need to do something here in the Arduino code in order to receive instructions through the serial communication port. Let's see how to do that. The first thing I'm going to do is to go here to the setup, and I'm going to start the serial communication port by doing something like this. Serial.begin, and I'm going to set the baud rate to something like this number over here. Okay. And then we will need to install a library which is going to be very helpful to process all the data we're going to receive from the serial communication channel, right? The library is called Arduino JSON. This library over here, you can see I have already installed it. So before you continue, make sure you install this library over here. Now I'm going to go here, and I'm going to include the library by doing something like this. Include Arduino JSON.h. Okay, and now we will need to create an object over here which we are going to use in order to save all the information we receive through the communication channel. So this is going to be JSON document, is going to be the type, and then the name is doc. Okay, now let's scroll down over here. And this is what we will need to do in order to read all the data we receive through the communication channel. So if we have received something, if serial avail greater than 0, if there is at least 1 byte in the channel, then we are going to run this code over here. The first thing we're going to do is to read all the data, right? So we're going to define a new variable which is pulse info. I'm going to show you why in a few minutes. And this is going to be serial read string until the new line character, right? So this is just going to take care of reading all the data we have in the channel until we find this character over here. Okay, and then we're going to call the serialize JSON. This is a function from the library we just imported. This serialize JSON, we're going to input doc and also this new object over here, pulse info. Okay. And then we are going to send 3 values through the channel. The first one is going to be the speed at which we want to move the motors. So this value is going to be something like speed. Perhaps I can, I can define it over here. The counter, this is only for test purposes. For now, let's just keep it. We're going to delete it in a few minutes, but for now, let's keep it. So this is going to be speed, and also we're going to define the delay. We're going to define it over here. We're going to initialize it for now only. And then we're also going to receive the direction, right? If we move forward, backward, and so on. So this is going to be int direction. Okay. So now let's do something like this. Speed is going to be equal to duck speed. Not sure if I can use these quotes or I have to use double quotes, but let's try with single quotes for now. And then I'm gonna do the same for the delay. The delay, I'm gonna save it and I'm gonna ask for another key. I'm gonna ask for duration, right? Because this is going to be the duration of the pulse, and then direction. Okay. Okay, perhaps I can call this one also the duration, so everything is consistent. Yeah, so everything is more consistent. Okay. And now I'm going to define another function, which is clear serial buffer. This is a function we're going to execute after we read the data from the buffer. And this is very important because once we set everything up and running in the Raspberry Pi, we will be sending data continuously to the Arduino Uno. So we need to make sure that the Arduino Uno is reacting to the newest piece of information, right? We need to make sure everything runs in real time as possible. So once we receive an instruction, we're just going to take all the information, we're going to decode all the information, and then we're going to clear the buffer. If the Raspberry Pi wants the Arduino Uno to move the motors again, it will need to send a new instruction, right? This is going to be a bit better, so we make sure it's always reacting to the newest information. And obviously we need to define this function, otherwise it's not going to work. And let's define the function over here. So this is going to be void clear serial buffer, and basically we are just going to make a while loop while there's data in the buffer, something like this. We're just going to read all the bytes of data we have in the buffer, something like this. Okay. We're going to read the data and we're just going to discard all the data. And this is going to make sure that once we are decoding an instruction over here, then we're just clearing the buffer and that's it. Okay, and yeah, so this is going to be pretty much all. Now let's make sure everything is over here. So speed is equal to speed. Now I'm just going to delete this part over here. And I'm going to do something like this. I'm going to add an else statement. And if we have not received anything from the buffer, from the serial channel, so I'm going to set the speed in 0, right? I'm going to make sure the robot does not move. And then duration is going to be equal to something like, so a very low value, perhaps something like, I don't know, 50 milliseconds. We can make it even lower than this because we don't want to make this robot to be stuck, right? We want to make it always reactive to the new instructions which will be sent from the Raspberry Pi. So if we have not received anything, let's set it in a very low value, perhaps 50 milliseconds. And then the direction, we are going to encode the direction using integers. So we're going to use the number 0 for forward, then the number 1 for backward, 2 for left, 3 for right, and 4 for stop, right? So for now, let's just set it like this. Now this is going to be pretty much all. I have to delete this other part over here. Now this is going to set this speed over here. And then it's going to move in this direction. So now I'm going to do something like if direction equal to 0. Then forward. elif direction equal to 1 backward. If it's 2, then left. If it's right, if it's 3, then right. And I'm going to create another function for stop. And I'm going just in case, because if we receive something that doesn't make sense, just in case and to be on the safe side, we're going to stop it as well. Okay. Now let's create this OR function. This is going to be very simple. The only thing we need to do is to set everything to low, for example. And that's going to be pretty much all. So now let's continue. Then we're going to wait for this amount of milliseconds. And that's pretty much all. Then the counter, we don't really need it anymore, right? Yes, we don't need it anymore. Now it's going to move only one pulse, right? It's going to move for the duration of time we have specified here in duration, and then it's just going to stop because it's going to receive a piece of information, it's going to react, and then if it doesn't receive any new instruction, it's just going to be still and it's going to be waiting for new instructions, right? So this is going to be pretty much all. We don't need that counter anymore. So now let's see if it works. I'm going to upload the changes. Okay, we have an error. Over. Yeah. This is not Python. This is not Python. Okay. Oh, this is not Python, so this is else if. Okay, else if. Okay. Okay, perfect. Now let's see if it works. I'm going to open the serial communication channel. I'm going to open the serial monitor and let's simulate the instructions we will be receiving from the Raspberry Pi. Let's see what happens. So I'm going to input a dictionary. Let's write it over here. It's going to be much better. So this is going to be something like a dictionary. So the speed, let's say it in 128. The duration, let's set it in perhaps 200 milliseconds. And then the direction, let's set it in 0 for now, which is going to be forward. And we're just going to test all the different directions. So let's see what happens. In order to have some debugging information, I'm going to print this thing over here, string serial dot print this value over here. So we have some debugging information, right? So this is going to be pulse info. And then something is okay. Let's see now. Okay, we are receiving something, but it's not moving. It's not moving. So let's see what's going on. So we are clearing the buffer over here. Let's see if we are decoding all the information correctly. So I'm going to print something like speed something like this for duration and also for direction. Let's see exactly what we are receiving, what we are decoding, right? Perhaps it's these quotes over here. And probably I will need to cast it to string. Okay. Speed, duration, and then direction. Everything seems to be okay. Okay, monitor. Yeah, it's not working. Let's see why. Perhaps it has to do with the quotes. Perhaps this has to be double quotes. Okay. Yeah, make sure you're using double quotes over here because otherwise it's not going to work. So everything seems to be working just fine. I'm going to remove these prints over here so everything is much better. Going to upload it again. So let's try to send this message again and let's see what happens. And before I forget, this is very important. This is something I found out when I was preparing this tutorial. This message over here needs to be less than 64 bytes long. Please make sure that in case you make any changes to this project and you decide to input a different information over here, a different message over here, whatever message you input through the serial communication port, it needs to be less than 64 bytes long. Otherwise, you are going to have some issues once you try to read the message using the Arduino Uno, right? So now let's try again. Let's see what happens. So this is going to be 128, the speed, then the duration 200 milliseconds, and this is going to move forward. And you can see everything seems to be working fine. Now let's try the other direction. Let's try to make it move backward. And let's see what happened. And you can see that it also moves backwards, so everything's okay. Now let's try to move it to the sides. And remember, in order to make it move to the sides, by the way we are working here with the robot and everything, we need to simulate the load we will be having once everything is up and running. So I have added the power bank. Now I'm going to try to move it to the left. And it moved slightly to the left, so everything is okay. Now I'm going to try to move it to the right. And it moved slightly to the right, so everything seems to be working just fine. Now let's input another pulse, something like 500 milliseconds. You can see that now it moved for a longer period of time. So yeah, everything seems to be working just fine. Let's try to move it faster for 500 milliseconds and let's try to make it move forward. Let's see what happens. So I'm going to do something like this. Okay. Yeah, seems it's working fine. So this is going to be pretty much all for this part over here. We already have all the code we need in Arduino, right? Because now we are able to move the motors, we're able to move all the wheels, we have all the different directions we need in order to work on this project. We can also test the direction number 4 just to make sure everything is okay. And you can see nothing happens because it's going to be stopped. And if we input a different number over here, 6, okay, nothing happens, so everything is working properly. So all the different directions are ready. We are able to send data through the serial communication channel. Now everything is ready. Now let's go to the Raspberry Pi and let's make sure we are sending this data from the Raspberry Pi, right? Okay, now let me show you where I have connected the Raspberry Pi 5. If I show you over here, you can see that this is the Raspberry Pi. I'm using only one screw over here. This is 2.5 millimeters. I'm using only this screw over here, and I'm surprised how stable it is. I have been doing many tests already, and I found it's very stable in this position. It doesn't move. So let me show you. This is the USB cable which I have connected to the Arduino Uno. So I have connected the Raspberry Pi 5, and now let me show you how to use it in this project. Let me show you everything we need to do in order to make it work. The first thing I'm going to do is to SSH into the Raspberry Pi. So I'm going to go here to this terminal, and I'm going to type something like this. My username, which is felipe@raspberrypi.local, which is the name of the Raspberry Pi in my local network. So I press enter. Let me show you something, which is what's my OS. If I type this command over here and I press enter, you can see I'm using Ubuntu 26.04 in my Raspberry Pi. That's very important. If you're using a different Ubuntu version, things may be a bit different. So this is a very important detail. And now let me show you what's my ROS2 distribution. If I LSOPT ROS, you can see this is my ROS2 distribution, which is lyrical. This is also very important. At the time of recording, this is the newest version of ROS2, and this is the one I'm using in this project. And let me show you also what's my Python version. I'm currently using Python 3.14. If I show you something like this, Python 3 over here, Python 3.14. So yeah, this is only a few details. These are a few details so you understand exactly what are the different specs of all the different components I'm using in this project. Now let me show you something else which has to do with the architecture of exactly what we will be doing today when it comes to ROS2. Let me show you this image over here. So this is the overall high-level architecture of everything we will be doing today. We are going to be creating two different nodes in ROS2. One of them is called teleop robot and the other one robot controller. And they will be exchanging information using this topic over here, which is called teleop robot commands. So this is everything we will be creating in the Raspberry Pi. Let me show you. Now I'm going to open my Visual Studio Code. I am going to open my Visual Studio Code in my computer, in my desktop computer, but I will be communicating with the Raspberry Pi using an SSH connection from Visual Studio Code, right? This is going to be a very interesting feature from this IDE, and let me show you how to set it up. Basically, you need to go here. You need to go here to this tab over here, Remote Explorer, and this is where you will be able to just create a new SSH connection. You're going to input the username at the server name of your Raspberry Pi, and then you're just going to input your password, right? You can see that in my case I already have this connection over here, which is raspberrypi.local, and the only thing I need to do is to click in this button over here, and this is going to prompt for my password, right? You can see enter password for felipe@raspberrypi.local. So I'm going to do that. And that's pretty much all. So this is a very interesting functionality from the Visual Studio Code IDE. And this is what we will be using in order to work on this project. This is going to make things much easier. Okay, perfect. So this source directory is currently empty, so we have absolutely nothing over here. Now let's get back to the terminal in the Raspberry Pi because we will need to create a new package, right? Let's start creating the interface we need in order to publish data here in this topic. We will need to create a custom interface in order to publish our custom data. Let me show you how to do that. So let's go back here to the terminal, and I'm going to type something like this. Let's remember exactly what's the command we will need to execute. I'm going to execute this command over here. So this is going to be ROS2 package create build type amend cmake, and then let's call this new package teleop interface. But obviously, in order to do it, I will need to be in the workspace, right? So I'm going to ROS2 workspace, then src, and now let's type this command over here. Okay. Oh, I have slash missing over here. Okay, now everything's okay. So we have created this package, which is teleop interface, and now let's build this workspace. So I'm going to call colcon build, and I'm going to do it with symlink install. Okay, everything is okay for now, but obviously we will need to create this package. So let's go back here to Visual Studio Code, and I'm going to create a new directory which is called message, right? We will be publishing messages into a topic. So I'm going to create this directory over here, and then I'm going to create a new file which is called teleop.msg. Okay, so this is going to be a very simple message. Let's make the font size something like perhaps 16. Okay. And now this is going to be something like a message of type string, and this is going to be the direction, because we are going to publish a string with the direction, which is going to be something like forward, backward, left or right, and then internally we are going to map those strings into integers, right? So everything communicates with the Arduino Uno very nicely. So this is going to be pretty much all for this file over here. Now let's go to CMake lists, and remember, every time we create a new interface, we will need to add some things over here. I'm going to delete all these comments. Okay, we will need to add a few instructions. Let me show you. Remember, this is always going to be the same, and it's a bit confusing because it's not very clear why this is needed, but let me show you. So we are going to add this instruction over here right after this find package. We are going to find this package over here, and then we are going to copy and paste this other instruction, right? ROS2 generate interfaces, and then the one we created, which is message teleop.message. So this is going to be pretty much all for the CMake lists. And now let's go to package XML, and this is going to be even more weird, because now we will need to copy and paste these three instructions over here, which are these three instructions over here: build depend, exec depend, and member of group, with these values over here. And please remember to do it before you continue. This is something we need to do every time we create a new interface. Just make sure you copy and paste these instructions over here, and also this instruction over here. Now, just to make sure everything's okay, I'm going to try to build the package again. Now it takes a bit more time because now we have created some content over here. Okay, and let's see if we can find this new interface we created. In order to do it, I'm going to source bash rc again. And now we should be able to ROS2 interface show. Then this package was called teleop interface message teleop. Okay, string direction. So everything is okay. Let me show you, just in case, what's the content of my bash rc file. Because remember, now I'm working on my Raspberry Pi, right? This is a terminal on my Raspberry Pi. So it's not the same to my my desktop computer. And if you have watched my previous tutorials, let me show you, because it's not exactly the same. I have added these 3 instructions over here, which are the source of the ROS2 package, the ROS2 distribution, then colcon, and then the directory of the workspace, right? The install setup sh in my workspace over here. So yeah, this is the content of my bash rc file. And now let's continue. So we have already created the interface we need in order to communicate with this topic, right? In order to publish data into this topic. And now let's get started perhaps working on the robot controller. Perhaps let's get started over here, because everything we need to do in the robot controller is going to be much simpler. Then later on we're going to move over here, and this is going to be a bit more complex. So let's take it one step at a time. So I'm going to create a new package, and this is going to be called, I'm going to the src directory, and this is going to be, let's make this one with ament c, I think this was ament python, and then the package name will be, let's call it robot controller. Or perhaps we can call it robot car, right? Because we're building a robot car. Okay. Clear. And that's pretty much all for now. Okay. Now let's get back to Visual Studio Code. Okay. And let's go here to robot car. Directory robot car. And then let's create a new file, which is called robotcontroller.py. So let's get started with something very generic, as we usually do, by saying something like this: if name equal to main, then execute main. Okay, this is very generic, this as we usually do. I need to make sure we can execute this file as a script. Now let's create the main function, which is going to be something like this. It's going to receive arguments. The default value is going to be none. And then we are going to do something like this. We need to import rclpy, and then we are going to initialize the communication with ROS2. So rclpy.init, and we're going to input the arguments. Okay. Then we're going to create a new node. So robot controller equal to robot controller, and the name of this class will be something like robot controller node, something like that. And obviously this is only one L, right? Robot controller, or is it 2 L's? It seems it's 2 L's. Okay. Just to make sure. Yeah. So robot controller, okay, everything's okay. And we need to create this class over here. So I'm going to define it over here. Class robot controller. This is going to receive, this is going to inherit from the node class. And obviously we need to import it over here from rclpy.node import node. right? Remember that this is how we specify in Python that this class over here is a child class of this other class over here. So we are inheriting the behavior of this other class over here, of the parent class. So the first thing we're going to do is to define the constructor, which is something like this. We're going to receive the name and also the self class like this. And this is going to call the parent constructor, the parent class, by calling super init name. Okay, so this instruction over here is going to call the constructor of the node class, right? And now let's move on. And the first thing we're going to do is to create a subscription, right? Because we are going to subscribe from here. We're going to subscribe to this topic. So let's create a subscription. This is going to be self.subscription. Create subscription. And the message type will be the one we created, which is teleop. Obviously, we need to import it. So we're going to say something like from tele. Let's see what was the exact name. Teleop interface message teleop. Okay. Teleop interface message import teleop. Okay, this class over here, teleop interface.message import teleop. Perfect. Then we will need to specify the name of the topic, which we say was something like this, teleop robot commands. Okay, then we are going to define a callback, which we're going to create in a few seconds, and this is going to be called something like listener callback. So this is the callback which will be executed every time a new message is published into this topic. And then let's specify this OR value over here, which is 10, right? And remember, this is a very commonly used value for this parameter over here. This is a much more complex topic in ROS2, right? So let's say one step at a time. For now, just set it in 10 and it's going to work just fine. And obviously we need to define this function. So I'm going to say something like def listener callback. This is a member of this class over here. This is going to receive self. And every time we receive a message, this is going to receive self and also message. Let's call getLogger. And let's see exactly what we have received, right? This is going to be something like this. Message direction, right? It's the only data we have in this data type teleop, right? Remember, is the only data type we have here, direction. And then let's move on. Let's define the data we need, right? And remember, we will need to provide a dictionary that looks like this. 3 different keys: speed, duration, and direction. So let's create that dictionary. I'm going to say something like this: request equal to a dictionary. Let's just copy and paste this part over here. Okay. Now we will be receiving the direction from the callback, right? From the message that's being published in the topic. We will be receiving the direction. But these two things over here, the duration and the speed, we will need to set it here in the robot controller. We are going to hard code it for now because, yeah, let's just, to keep it simple, let's just hard code some values for the speed and the duration. So I'm going to create some variables over here. Self.speed, this is going to be equal to 128. I think that's a good value. And then the duration, self.duration. I'm going to set it in 100 milliseconds. I have been doing some tests already, and we want the robot to move very smoothly and very fluently, and we want to make everything in real time as possible. So I have been doing some tests already, and with 100 milliseconds for the duration of the pulse is going to be enough. So this is going to be 100, and that's pretty much all, right? So I'm just going to copy and paste this value over here and this other value over here. So that's pretty much all, and then we will need to take the direction we have received over here. And the direction, remember, we have received a string, but we want to make it into an integer value. So let's define another dictionary, which is going to be something like direction to int, something like that. And this is going to be forward, it's going to be 0, I don't know what happened over there. Okay, we will have 5 values, right? Forward is 0, then backward is 1, left is 2, right 3, and then stop is 4. Okay, so then the only thing we need to do is to perhaps create another variable over here. Direction to int, message direction. Okay, and then the only thing we need to do is to input this value over here, and that's pretty much all. Let's make sure this is an integer, so I'm going to cast it as an integer. Okay, and now the only thing we need to do is to send this data through the serial communication port. So I'm going to import another library, which is PySerial. And we're going to import it like this, import serial. I definitely recommend you to check it out. The name is PySerial. Let me show you something. If you go here to getting started, you're going to see a few snippets on how to use the library, and this is going to be very useful. We have already used this library in some of my previous tutorials, and we are going to continue using it today, right? Today we're going to use this part over here, which is how to send data through the serial communication channel. So let's just go back here. I'm going to close the browser. I need to input my password again for the SSH connection. For some reason this is needed sometimes, every once in a while. Okay, now let's create a new object in order to be able to use this library. So I'm going to call this new object serial port, and this is going to be equal to serial dot serial. We need to specify the USB name, right? The port name, which in my case is dev tty USB 0. Okay, and we also need to specify the baud rate, which in Arduino I had set this value in 115200. This is very important to match this value to the baud rate you have specified in Arduino. It's very important. Now, how can you make sure of what's the right name you need to input here, right? In my case it's dev tty USB 0, but how can you make sure in your case? So this is what you need to do. Go back to the terminal where you have the SSH connection with your Raspberry Pi, and you need to ls into dev tty and this character over here, and this is going to give you all the connections you currently have, right? These are like USB connections, and more. And I'm not completely sure what exactly is everything that's over here, but the USB connections will be included in whatever all these values over here are. So you can see that this is mine, dev tty USB 0. Currently the USB port is connected, the USB cable with the Arduino is connected. If I disconnect it, something like this, and I run this command again, you can see that now this value disappears, right? If I connect it again and I run the same command again, you can see that now I have this value again. So just make sure you connect the USB cable, run the command, disconnect it, run it again, and it's going to be very clear what's the name of your USB connection in the Raspberry Pi. So now let's clear this output over here and let's get back to this code over here. So the only thing we will need to do is to communicate this object we created over here, this dictionary we created over here. We need to communicate to the Arduino Uno. So, and that's pretty much all, because everything else is ready. So the only thing I'm going to do is to call this object over here, serial port, right? And then I'm going to, this is going to be a string actually, right? And as we have a dictionary over here, the way we are going to take a dictionary and we're going to convert it into a string is by calling json.dumps. So this is going to be json dumps, and then we're going to input requests. Okay, something like this. Obviously we need to import JSON. Okay, and that's pretty much all. We are also going to send the new line character. Remember, we are from the Arduino side, we are reading the serial communication channel, and we are just reading until we find one of these characters. So we need to make sure we are sending this character. And then also we need to encode the string, because otherwise it's not going to work. And that's pretty much all. So this should work. I'm going to do something which is printing this value over here. I'm going to take all this string and I'm going to print it over here, just to make sure everything is working as expected. Okay. Yeah, everything seems to be just fine. Obviously, you need to install this library. So if you have not installed this library already, make sure you install it by running pip3 install. You can see I have this error over here because I am trying to install this library globally, which is not a good practice. It's not a good thing to do. So if you have a similar error, then you will need to create a virtual environment and you will need to install the package in the virtual environment. Let me show you how to do it in case something like this happens to you as well. I think it makes sense. I mean, it's not a good practice to install a package in the global environment, but for the sake of simplicity, I was going to do that in order to show you. I already installed PySerial in my global environment. If I do pip freeze, you can see that PySerial is over here. I have installed the version 3.5, but it seems something has changed from the last time I installed a library in the global environment. So let me show you how to create a virtual environment so you can install the library there. I'm going to go to src, going to clear this terminal, and perhaps we can create a new virtual environment in the same directory we have used for this package, right? So I'm going to robot car, and this is where we are currently working. And yeah, let's create the virtual environment over here. It doesn't make a difference. Let's just create it somewhere. So I'm going to call virtualenv bemp python 3.3. It's something that's very important is that whatever version you have used, whatever Python version you have used in order to install ROS2, it needs to be exactly the same version you are going to install here in the virtual environment, right? This is very important, super important, because obviously otherwise it's not going to work. So we have created a new virtual environment. If you have any error when running this command, then you will need to install virtualenv, and most likely the terminal is going to tell you what's the command you need to execute. So let's just source this virtual environment, something like bin activate, and then I'm going to pip install PySerial. Okay. If I do it from the virtual environment, I don't need to type pip3, but only pip is enough. Okay, so I have installed the version 3.5 in the virtual environment, right? Now if I ls bemp leave Python 3.14 and side packages, for some reason this is very slow. I don't know if it's the internet connection or something. Okay, so my connection is very slow for some reason, and while I was waiting, it took a few seconds, and while I was waiting, I pressed enter many times. So yeah, so anyway, this is the ls over here. You can see that this is the library we have just installed, which is PySerial, right? I don't know if you can see it because I have my my camera over here. You can see that this is the ls and this is the PySerial library. So later on, I'm going to show you how to run the packages using the libraries you have installed here, right? If you cannot install PySerial in the global environment, which I guess you should not do because it's not a good practice, then you need to create a virtual environment, and I'm going to show you how to execute the nodes using the libraries you have installed over there. Okay, so everything seems to be pretty much ready. The only thing we need to do now is to spin the node, because otherwise this is not going to work. So I'm going to call rclpy.spin, and then I'm going to input the robot controller node, and that's pretty much all. Then I'm going to call rclpy.shutdown. Okay, so this is pretty much all over here. We still need to do a lot of debugging. We need to make sure everything works as expected, but for now we can just move on. So this is just going to be subscribed to this topic over here, and every time we receive a new message in this topic, this is going to trigger this callback over here, which is going to just send all the data to the Arduino Uno. For now, let's just move on, and let's move on over here on this other node, which is teleop robot. Remember, the idea is to use our keyboard in order to input instructions and in order to operate the robot using our keyboard. So let's see how to do that. Everything has to do with the robot controller, although we need to do a lot of debugging for sure. For now, let's just move on and let's focus over here. So this is going to be pretty much all. I'm going to save the changes, and something I'm going to do before we continue is to make the font size a bit smaller, right? I think it's a bit too much. I think 18 was a bit too much. I think 16 is going to be a bit better. So now let's go here and let's create another file, and this is going to be called something like teleop robot.py. Okay, and this is going to be, let's just copy and paste the code we have over here for the robot controller, and let's just remove everything that we do not want, right? Let's remove all the content of this class until over here, and this is going to be teleop robot. Yeah, let's call it teleop robot. And now this is going to be teleop robot. We don't need the serial package anymore. We don't need the JSON package anymore either. And that's going to be pretty much all. Now this is going to be robot teleop. And now teleop robot node. Okay, so yeah, let's just start working on this structure over here. So this is going to be much simpler than before. Remember, the only thing we need to do now is to just listen to keystrokes in the keyboard, and every time the user press one of the keys we are interested in, we should be publishing a message into the topic. So this is going to be very, very, very simple. Let's write the content of this class first. So we are going to publish data into a topic. So we're going to create a new publisher. This is going to be self.publisher equal to create publisher. And the data type will be teleop. Then the topic name will be exactly the same topic name we have over here, teleop robot commands. And that's pretty much all. Then let's set this other value in 10 as well. Okay, so the data type and the topic name. Now let's create a new timer, right? Because we are going to execute a callback every given amount of time. So let's create a new timer in order to do that. Actually, we're going to call this function only once, but let's just pretend we're going to call it many times, right? So let's create this timer like this. Self create timer. We are going to call this function every 100 milliseconds, and then the name of the function we're going to execute will be something like timer callback. Okay, remember, I'm going to show you now that actually we're going to execute it only once, but anyway, this is the way we need to do it. So this is going to be self timer, no, the definition is def timer callback. We're going to input self, and that's going to be pretty much all. Then we're going to create a new object in order to send to this topic, in order to publish in the topic. So this is going to be topic. Then the direction will be the direction the user has input in the keyboard, right? For now, the only thing I'm going to do is to call an internal variable, which is going to be self.direction, and I'm going to initialize it over here. I'm going to initialize it as stop, right? I think it makes sense. Remember, we are publishing strings, and then these strings are converted to integers, but for now we are just publishing strings. And then the only thing we need to do is to publish this message. So self.publisher .publish message. Okay. So the only thing we need to do now is to add some code over here so the user can control the robot using its keyboard. And this is how we're going to do it. I'm going to do something like this. I'm going to work on a while true, and we are going to spin the node, but we're not going to spin it like this as we have done so far in this video and in previous videos. We're going to spin it only once, and if I'm not mistaken, this was spin once. Yes, spin once. So we're going to spin it only once because we are going to execute all the code we have over here in the callback, but we're going to execute it only once every time we receive a new instruction from the keyboard, right? It makes sense. That's why I was telling you guys that, yeah, we create this timer. This is going to be executed every 100 milliseconds, but as we are spinning the node only once, this is going to be executed only once. So let's continue. And now we need some code over here in order to be listening to the keystrokes. And this is how we're going to do it. We're going to define a new variable, which is char. And char will be, we're going to create a new function in a few minutes, which is going to be get key. But for now, let's just write it like this. And this is going to receive some parameters, which I'm going to tell you also in a few minutes. But for now, let's continue and let's focus on everything that comes after getting the character the user has pressed. So we're going to ask something like this. If the character is a W, then we are going to set this variable over here in forward, right? And this is how we're going to do it. The variable name, actually this should be teleop robot, right, in order to be consistent. And we're going to say teleop robot dot direction equal to forward. Okay, and then we are going to move on. Then we are going to ask if the character is the letter S, and in that case this is going to be backward. We're going to use these keys over here. So WS, then A is going to be left, and then D is going to be right. Okay. And then if the user inputs the letter Q, we are going to terminate the program. Right? Because we need to have a way to terminate the program in case the user has not input, in case the user wants to leave, right? Remember, we are in a while true over here, so it makes much more sense to do things like this. Okay, so that's pretty much all. That's a very basic functionality, but that's pretty much all. Now let's see exactly what goes here in get key. And this is a function I'm just going to give you. I'm just going to copy and paste it over here. This is a function I got using Cloud. Cloud gave me this function and it's a bit messy. Let me show you. We also need to make a few imports, which are tty, terminus, and select. So I'm just going to import it over here. And also we need to import sys. Right, these 4 libraries over here, these are Python built-in libraries, so we do not need to make any install or anything. These are built-in libraries, and this is pretty much how the function over here is going to work. Just remember that this is a function we're using in order to listen to keystrokes from the keyboard, and we're going to read 1 byte at a time. So we're reading 1 char at the time. Every time we call this function, if the user has input something, then we are going to get what's the character the user input. So I'm just going to copy and paste these values over here. Okay, I need to define this parameter, this object, which I'm going to define it over here. This is something like terminus get attribute. Okay, if I'm not mistaken, something like this is going to work just fine. We could have a print over here, so we let the user know how to use this keyboard in order to control the robot, and we could do something like please use a to control the robot. We don't need to use please actually, so let's just print this over here, and that's pretty much all. Okay, and we can also print press Q to exit. Okay. So that's pretty much all. We're going to initialize it over here. We're going to create a new instance of this node. Then it's going to execute this code over here. It's going to create the publisher, and the first direction will be stop, and everything is okay. Then we move here, while true, we're going to spin this node only once, so we're going to publish this direction, but this is stop, so it doesn't make a difference. Then if the user has input a key, we're going to get the value over here, and that's pretty much all. Forward, backward, left, right. Q break. Shutdown. Yeah, everything seems to be working just fine. So let's see if it works, right? Let's see if it works. So everything is already connected, the Raspberry Pi, the Arduino Uno. So let's go back to the terminal over here in the Raspberry Pi, and I'm going to build the project again because we have created these two classes, the robot controller and the teleop robot. And let's do that. Obviously we will need to go here, setup.py, and we need to add these two scripts over here, right? So let's start with the teleop robot Python file, and this is going to be something like teleop robot node, and this is robot car, which is the package name, right? Robot car, then teleop robot, and then the main function. Okay, and then we need to do the same for the other file. This is robot controller node, robot controller main. Yes. Okay, so now let's go to the workspace and let's just call build Symlink. Okay, and that's pretty much all. Now let's see if it works. So I'm going to execute. No, I will need to source the bash rc again. Robot car. Okay, everything seems to be working. And now let's go to another terminal. Here. And let's type okay, we are receiving something is not right. I think the problem is over here. It's not actually a problem, but we can make it a bit better because we do not need to send stop every time the user does not input something, right? So let's do something like this. Let's define another variable, which is press key, and this is going to be a Boolean variable, which is equal to true at first. Okay, and if press key, then we're going to spin the node once, and then we set it to false over here, and if the user input something, we can do it like this. Yes, and we can make it like else. Press key. Okay. Yeah. Okay, yeah. Something like this should work fine. Let's see now. Okay, now we received stop, but only once. Okay. And now let's press the letter W. Let's see if it works. It worked. Okay, okay, it works. Now let's see if we make it run backward with the letter S. Okay, yeah, it worked too. And let's see with the letter D moving right. Okay, it's not moving right because of the weight. We can make it like this. Yeah, everything seems to be working just fine. So that's going to be pretty much all for now. You can see that everything is pretty much ready. Everything is ready. The only thing we need to do now is to add the camera, the webcam, and also I am going to show you some things that have to do with the power supply. We're going to add the power bank, and I'm going to show you some details. I'm going to tell you some details that have to do with the power supply. So this is the USB camera I will be using in this project. You can see it's a very traditional USB camera, and I'm just going to put it here in the frontal part of the robot, and then the USB cable goes here in the Raspberry Pi 5 in one of the USB ports. And you can see that in my case the cable is a bit long, so I ended up using one of these clips, so everything is much nicer and the cable is not all over the place on top of the robot. Now let me show you how I visualize my USB camera connected to the Raspberry Pi from my desktop computer. This is going to be very straightforward, and the only thing we will need to do is to execute these two commands over here. We could do it in various ways, we could do it in different ways, but I think this way to do it is very straightforward and it works pretty well. So the only thing you need is FFmpeg, so make sure to install it in the Raspberry Pi if it's not installed already. And other than that, everything is going to work very smoothly. So let me show you. The only thing we need in order to execute this command over here is the desktop device IP, right? So I have my Raspberry Pi 5 over here, and then I have my desktop computer, right? Both devices are connected to the same network, right? To the same local network. So I need to find this number over here, which is the IP of my desktop computer in my local network. And in order to get this number, the only thing I need to do is to execute this instruction over here. So I'm going to execute a terminal. This is my local computer, and I'm going to run this command over here, and I get this number, the 192.168.046. So this is the number of my desktop computer in my local network. The only thing I need to do is to copy this number and to paste it over here and over here. And then I'm just going to copy and paste this instruction in the Raspberry Pi. Remember, you need to install FFmpeg if it's not installed already. If I'm not mistaken, if FFmpeg is not installed in the Raspberry Pi and you try to execute it, the terminal is going to suggest what's the instruction in order to install this library, right? So I'm just going to copy and paste, and that's going to be pretty much all. I'm going to press enter. Now I'm going to open another terminal in my desktop computer, right? This is my desktop computer, and I'm going to execute this other command over here in my desktop computer, and in order to do so I need to install use ffplay. If I'm not mistaken, when you install ffmpeg, it's going to install this other utility too, if I'm not mistaken, but if not, you will need to install it independently. And then I'm just going to execute it. It's going to throw errors for a few seconds, but eventually it's going to receive the frames. Okay, there. Okay, so everything seems to be working well. It's not working real time. You can see that it's not like entirely real time. We have a very small delay, but I will say it works very well. Let me move it around a little bit. Okay, you can see my camera, my lights, my monitor, and it's not like entirely real time. For example, now I'm moving my hand and you can see there's a bit of a delay. I'm going to move this over here. There's a bit of a delay, but only a bit of a delay. It's not a huge delay. Okay, so that's pretty much all. In case it helps, something I tried, and I think it helps a bit, not a lot, but a bit, is to reduce the video resolution over here. You can see it's currently set at 1024 and 786. If I make it something like 640 and 480, I have the impression that it works a bit better. A bit better. I will run it again. I have the impression that now the delay is a bit less. I have the impression. Yeah, I think it works a bit more real time. But even if there's a delay, it's only like, I don't know, not even 1 second, right? It's like a very, very small delay. Only a little bit. It's not really that much. So that's going to be pretty much all. This is exactly how we're going to visualize the video stream from the webcam. And now let's move on and let me share some comments regarding the power supply we will be using in order to power the entire robot. So this is the power bank I will be using in this project. This is a 22.5 watts power bank, and I will be using it in order to power the Raspberry Pi, only the Raspberry Pi. I will be using one of these USB ports, the USB-C port, and that's pretty much all. And then I'm gonna be using this battery, this 9 volts battery, in order to power the motors, only the motors. This is a rechargeable battery, so it's very convenient to use in a project like this. And remember, this is only for the motors because I will be using the power bank for the Raspberry Pi. Looking at the Raspberry Pi 5 original adapter, it says it supplies 27 watts. So I was a bit surprised when I noticed I was powering the Raspberry Pi with only 22.5 watts. So yeah, I was a bit surprised, but everything seems to work well. I didn't notice anything unusual and everything seems to be running without any issues whatsoever. And then I will be using this box over here. This is a box I made myself in FreeCAD, and then I used a 3D printer in order to print the box. And yeah, this is going to help me a lot in order to make the power bank a bit more stable and a bit more in a fixed position on top of the robot. It was a very easy and a very quick solution in order to make the power bank to be in a fixed position. And based on all the tests I made so far, it works very well. Everything stays in a very fixed position, so yeah, it works very well. Okay, now let's see if the entire robot works as expected. We have already tested each part in this project independently, but now it's time to test the overall system, right? Let's see what happens. So I already SSH'd into the Raspberry Pi 5, this is my Raspberry Pi, and now let me show you first how to use the Python packages you have installed in your local environment. In case you have installed PySerial locally in your local environment, in your virtual local environment, let me show you how to use those libraries. So it's going to be very simple. The only thing we need to do is to run something like this. I'm going to go to my workspace, then I'm going to go to my source directory, and let's see exactly how to do it. Python path, something like this. Yes, we will need to add the location of the virtual environment to our Python path, so everything works as it should be, right? In my case, it's not absolutely necessary because I also installed PySerial in my global environment, but it doesn't matter. Let me show you how to do it. So basically, we need to export this Python path over here, but let me do something first. I need to update this directory. Now this is robot car, and we can make it, perhaps we can do something like this, okay, let's see if it makes sense. Yes, here is PySerial. Okay, and now I'm going to execute something like this for the teleop robot node. Let's see if it works. Everything seems to work as expected, no errors so far. And now I'm going to open another terminal. I'm also going to SSH into the Raspberry Pi. And I'm going to execute the same commands. Actually, exporting this path to the Python path was necessary only for the robot controller, right? Because this is where we are using PySerial, but it doesn't matter. Then I'm going to run something like this, and then robot controller node. No error whatsoever. Okay, so if I start the program again, we are sending the stop direction. Everything's okay. And now let's run in another terminal. Perhaps here. This is also in my Raspberry Pi. I'm going to run this over here. Okay. If you have a similar error, if it says something about you don't have the necessary permissions in order to access the webcam, you need to execute this command over here. This command over here. So you need to provide your USB port the necessary permissions in order to be able to access the camera. Okay, let's try again. Now everything's okay. Now I'm going to open a terminal in my computer. This is in my computer. And let's see what happens. Okay, so this is the webcam in the robot. I'm using another camera over here in order to record the entire robot and everything and all the environment and everything. So I'm going to keep this open over here and let's hope it works, right? Let's hope it works. So this is where we will be teleoperating the robot. Then let's keep this other window open too, just in case. So because we're going to have some debugging information over here. Something like this. And let's see what happens. So I'm going to press the letter W. And you can see something is going on, right? Something is happening. Okay, yeah, it seems it's working. Now let's move it backward because I'm not looking at the robot directly. So I have to trust what I see in the camera. I think the moving right didn't work very well. Perhaps if we do something, I'm going to do something very quickly, which is increasing the speed, right? I think it's moving very slowly because now it has the power bank on top. So let's do it very quickly. I'm going to Nano ROS2 workspace. This is SRC robot car, and then robot controller. Robot controller.py, and I'm just going to change it to something like, perhaps, let's make it 255. Let's make the maximum speed and let's see what happens. Okay. Let's try again. Okay. I think I like it a bit better like this. So this is going to be all for this tutorial. I hope you enjoyed it. I enjoyed a lot working on this project, and see you on my next video.